This call is now being recorded.
Okay, just a few minutes ago, you had this warm-up problem that's going to lead us into the discussion of Module 3, Lessons 1 and 2. So we're going to kind of, we're going to try to get to through all of Lesson 1 and 2 in one day. And it starts with sort of reviewing what you came up to be the pattern for the sequence behind me, as well as filling in the missing values. So let's review what you should have come up with. First of all, you should have noticed as you sort of analyze the numbers that this sequence, and it's called a sequence, if you don't pick up the pattern in maybe the first two numbers, if you just simply keep going, you could see that there is a pattern. And if you look closely, it seems like we're adding 4. And if you take your calculator, you're going to find that's the case between -3 and 1 as well. Now, we have seen this earlier in the year in the form of a table. So earlier in the year, we said, and we worked with X and Y, and sometimes we even called this X and f of X for function notation, remembering that that's all the same. The second term was -3. The first term, we don't know what that is. And then the third term and the fourth term, well, second produced -3, the third term produced 1, the fourth term produced 5, and then this fifth term produced a 9. And of course, you then had to come up with what's the sixth and what's the seventh. So earlier in the year, as I mentioned, we looked at tables and we said, well, we noticed that there was a pattern here of adding 4. And this was called a common difference. And because of that, we said this indicates a linear function. A linear function. So by that, we can then just simply add 4 to get 13, and we keep the pattern going, and we get 17. And if we go backwards, here, we're going to subtract 4, and we notice that the term that we get there for the first term, well, the first term is going to be -3 minus 4, which is a -7. And so that's why you should have gotten these answers for your warm-up problem. -7, 13 and 17, and the pattern was adding 4. And the connection to previous knowledge is the table on the right that we should be familiar with. And one little trick you could do is when you get these is to say, well, I can do my own table. This is the first term, second, third, fourth, fifth, and sixth. So that's another way of looking at that. Okay? So let's take this warm-up problem and now let's look at sequences and what we're going to do with them. So in this particular lesson, 1 and 2, it deals with looking at integer sequences as well as this new concept called writing the recursive formula. Writing the recursive formula for a sequence. And in fact, it's a very simple concept. But let us start with analyzing this number sequence, 4, 7, 10, and 13. We first have to find what is the pattern. And the pattern can be found by simply doing the same thing we've been doing. And once again, you could think of this as a table. And you could think of this as, for instance, X and f of X. And you could put, for instance, your first term was 4, your second term was a 7, your third is 10, and your fourth term is a 13. So I just want to connect it to previous knowledge. So if you need to put it in the table, feel free. But first, the pattern. It seems that we have a +3, +3, and +3. This is what's called the common difference. It's also known as the rate of change, which is also known as the slope of a line. And so this allows us then being able to determine what the pattern is and being able to determine a few other things that you're going to see in a second. It allows us to write an equation or a formula for this sequence. And so what we want to do is notice this idea of recursive. Recursive basically means the new term can be found by taking the previous term and adding the D, or adding the common difference. So recursive is just about finding a new term by taking the previous term and adding the common difference to it. So in this case, how we would write the recursive formula is we always state the first value. In this case, the first value is f of 1 is 4. And then f of n, any other term, is going to be f of n minus 1, the previous term, plus, what's the d? Well, in this case, the d is plus 3. So right here is what's called the recursive formula, or the recursive way of writing this. Now, I'm going to show you something else that's called the explicit formula. The explicit formula is found, and we already have dealt with the explicit formula. For example, we remember that if we have a line like this written in this form, that is the slope, and this is called the y-intercept. This is also called the zero term. Okay, so in effect, if we take what we know about this sequence, and we know that we have the first term here, what if we wanted to know the zero term? What if we took this table and we said, can we find the zero term? In other words, we know that going this direction, adding 3, adding 3, adding 3. But what if we wanted to find going backwards, the zero term, which is also the y-intercept? Well, we would then subtract 3, and that would be 1. So that's really important, because as we go to look at writing the explicit form of this sequence, we now know that the slope is 3 and the y, or the zero term, is 1. That means, and we'll use function notation, and we'll use f of n to be similar to this one. F of n, also known as y. F of n, also known as f of x, right? Depending on what variable you're using. F of n is the slope, 3. The variable, in this case it's n, and then the zero term. And so in this case, we would recognize it in these ways as well. Recursive formula, explicit, and notice how I wrote it in some familiar ways there as well. I wrote it in familiar ways, y is equal to 3x plus 1, and that completes 2 different ways to recognize this sequence. Now, let's go back and double check. For instance, if we put in 1, we should get back 4. 3 times 1 plus 1 is 4. That checks. Put in 2. So take this and put in 2. Does that equal 7? And yes, it does. 2 and 7. So we can see that these 2 formulas, the explicit formula and the recursive, are 2 ways now that we can identify a sequence. Let's do one more example. So I'm going to find the explicit and the recursive on this one as well. First step, find the pattern. find pattern. In this case, the pattern seems to be plus 5. Okay? So this right here, again, if we say, well, we want to do a table because that's the first term, second term, third, and fourth. What's the 0 term? Well, the 0 term, if we're adding 5, we're going to subtract 5. And so that means 3 minus 5 is, 3 minus 5 is a negative 2. So we have our 0 term, which is equal to a negative 2. This is also known as the y-intercept. We have the slope, or the rate of change, also known as, yes, the common difference. And that's equal to plus 5. With this information, we now can write the explicit and the recursive. So let's do the recursive first. It's the easiest. The recursive formula says take the first term, f of 1, and what is it? Well, it's 3. It then says take f of n, we'll use f of n, is equal to f of n minus 1, and the common difference of plus 5. So be understanding where I got this number and where I'm getting this number. That's the recursive formula. Now let's find the explicit. So the explicit says, and we're going to write it as f of n. What's the slope? Well, the slope is 5. N, and then what's the 0 term? Minus 2. And so understand where I'm coming up with this number and where I'm coming up with this number. We should be able to do both, right? The recursive and the explicit given a sequence. And this sequence, by the way, this is called an arithmetic sequence. And it's also a linear function. And that'll conclude the video for lesson 1 and sort of gets into lesson 2. We still have, the next thing is, what about if the sequence is an exponential function, or otherwise known as a geometric sequence? We're going to look at that in the next video.